Okay, let's continue with this problem. With C, if we look at where C is living, it's right here. It's kind of hard to see. It almost looks like a G with how close it is to that 4. But the thing is, we don't have a G that we need to look for. So this one's our C. And again, we do horizontal movement first, which is to the left 2. So that'll be a -2. We put a comma. And then we look up, and we go all the way up to our Y, which is at 3. D is right here. We have no horizontal movement, you'll notice. It's right there on the y-axis, so that means we have a 0 in our x component, but we go up to 4 in our y, and so we have that. Our E is over here. It is to the right 3, that's our x, that's our horizontal movement, and then we go all the way up to a vertical movement of 6. Last one is F. We go over to 5 horizontally, and then we come down, it looks like, to 3. So it's a -3 because we came down to that. So remember, you have to use parentheses around these ordered pairs or you will get every single one of these wrong, and that would really, really suck. All right, graph by plotting points. This was from 4.2, and we learned later how to do this a little bit more efficiently. So you can still use the table and just pick random x points if you want, but honestly, I'm going to remember that this is written in y equals mx plus b. This is the equation of a line. This is our slope-intercept, where the m is our slope, and the b is our y-intercept. And that is written as a 0, comma b. So if I have y equals 4x minus 2, then from this equation, I know that my slope is 4 and that my y-intercept is 0, comma -2. This is great because that's all I need to know in order to graph this line. What I do is I go over here and I say, okay, 0, -2, that's going to be right here because that's your y-intercept. And then the slope is a positive 4. When you write your slopes over on the side or you're making these notes, if it's a whole number, stick it over 1. That way you can see the vertical change over the horizontal change, because slope is rise over run or vertical change over horizontal change. So if the vertical change is positive, like it is in this case, that means we're going to move up because positive vertical movement is up. The bottom number is positive, which means we move to the right because positive movement horizontally is to the right. So from the point 0, -2, we're going to go up 4, 1, 2, 3, 4, and to the right 1 unit, and we drop that. Then we connect it. I mean, in Pearson, if you're doing this, it automatically connects it for you. But since I'm doing mine on paper, I have to actually do the connection. And you can do a really quick mental check in that you have an equation that says y equals 4x minus 2. That means you have a positive slope, and as you read your graph from left to right, your slope is going up. Your line moves up, which means it has a positive slope. So that at least will tell you if you have, a similar looking graph. It doesn't actually tell you if you have the correct graph, but it gives you enough information to say, okay, well, at least it's going to look in the general way that it's supposed to. With 25, it says graph by plotting points. And again, you have the option of just picking random x values and plugging them in and chugging out your y's. I'm going to do it the way I did the last problem, but in order for me to do that, I have to get this in y equals mx plus b format. That means I have to get the y by itself. So in order to get y by itself, I'd have to add the 4x over. That would give me 7y equals 4x. Divide by 7, and I get y equals 4/7 x. And you're like, okay, but wait a second, this is supposed to look like y equals mx plus b, but there's no plus or minus number out here. And that's okay. If you don't have a plus or minus number out here when you get it written, you can honestly put +0 if you want to on your paper to remind you that, oh yeah, I can have a y-intercept at the origin at 0, 0. And that's what's going to happen in this problem. Because from this problem, I know that my slope is 4/7, and I know that my y-intercept is at 0, 0. So 0, 0 is the origin, so it goes right here through the middle. So I'm able to drop that point. And then my slope is a positive 4/7. That means I'm going to go up 4 and to the right 7 units from the origin. So I'm going to go up 4 units and then to the right 7, which actually starting at the origin makes it pretty easy because I'm going to go to the point 4 cents. And I drop that point. And then again, if you're using Pearson, you don't actually have to connect anything. But I'm doing it on paper, so I actually have to connect. And again, I can do a quick mental check in that I had a positive slope over here. So do I have a positively sloping line? I do. That's wonderful. Love it. And I can go on. Now, again, you could have done this a different way. You could have picked random x values, plugged it in. The risk you run in that is that you're going to have fractions or decimals. And so that's why your best option is always to get your equation into the y equals mx plus b format, plot your b, use your slope to plot your second point. All right, graph the equation. This says y equals 6. It gives you nothing else. There's no x component here. Remember, if you have y equals a number, this is a horizontal line. It doesn't matter what your x's are. There are no x's in the equation. So anywhere, as long as y is 6, you are good to go. And you can literally drop your points anywhere you want, as long as you stay on y equals 6. And then you have this nice horizontal line running through y equals 6. Don't make it harder than it needs to be. Don't freak out and think, I don't know what points to pick. As long as your y is 6, the rest of it is good to go. Using the slope formula, find the slope of a line through the given points. And they give us 2 different points. So you do need to know the formula for slope. I'm going to use a separate sheet of paper just so you have a little bit more room. So this is something you either need to have memorized or something you need to write down on your cheat sheet. But slope equals y2 minus y1 over x2 minus x1. And so if they give you 2 points, you can literally write those 2 points down and label them x1, y1, x2, y2. And no, it doesn't matter which one is point 1 and which one is point 2. It will work out as long as you don't try and intermix the x from this one with the y from this one. You'll be fine. So the way that I have mine labeled, y2 would be 1 minus y1, which is 5, all over x2, which is 2, minus x1, which is 6. 1 minus 5 is a negative 4. 2 minus 6, hey, that's also a negative 4. If you had the same thing on top and the same thing on bottom, that simplifies to 1. So the slope of the line is 1. That made it nice and neat for us. Determine the slope of the line and the y-intercept represented in the given equation. So they give you an equation, it's written in standard form. If you want to know the slope and the y-intercept, you need to put it in slope-intercept form, which is y equals mx plus b format. In order to do that, I would have to move the x component to the other side, so I'm going to subtract 5x from both sides. That'll give me a negative 2y equals a negative 5x plus 16. I wrote my x term first on the right-hand side simply because I know I need it to look like mx plus b over there. And so that's why I did it instead of writing 16 minus 5x. Now, to get the y completely isolated, I would have to divide by negative 2. So I divide everything by negative 2, again, because I want it to look like y equals mx plus b. The negative 2's with my y's cancel out, so I get y equals, and then here I have a negative divided by a negative, those cancel, and 5 divided by 2 doesn't simplify, so I have 5 over 2x, and then I have a positive 16 divided by a negative 2, positive divided by a negative is a negative, 16 divided by 2 is 8. So the slope of the line is the 5 halves. So I write that in my box, 5 halves. And then it says the y-intercept is, and here's the kicker, write it as an ordered pair. So I don't just get to write negative 8. I have to put parenthesis, 0, comma, negative 8, close my parenthesis. We have to be careful on that so we don't miss points by getting the right answer but giving it in the wrong method. So just be aware of that. 29, determine whether the pair of lines are parallel, perpendicular, or neither. So in order to do this, we have to write both of these equations in the y equals mx plus b format, and then we look at their slopes. If they're parallel, they will have the same slopes. If they're perpendicular, they will have negative reciprocal slopes. If you don't have either the same slopes or the negative reciprocal slopes, then you're neither. That's why it's called neither. All right, so I'm going to play with the top one in my blue pen. So I have, and I'm just going to rewrite it to get started with. We have 9x plus 3y equals 10. I need this to look like y equals mx plus b. So I'm going to subtract the 9x, subtract the 9x. That'll give me 3y equals negative 9x plus 10. And again, I wrote my x term first because I need it to look like mx plus b. I'm going to divide by 3, divide by 3, divide by 3. I'm doing the exact same stuff I did on the last problem, guys. And I get y equals negative 9 divided by 3 gives me a negative 3x. And then I have 10 over 3. Now, right now, that's what I have. And I can even make a note if I want to, just to save a little bit of looking later, that the slope of this first line is negative 3. So I need to figure out what is the slope of my second line, so then I can compare the two to tell if they're parallel, perpendicular, or neither. So my second line says 9x equals 27y plus 36. I need to get y by itself, so the first thing I'm going to do is subtract the 36, subtract the 36. And I get 9x minus 36 equals 27y. I need to get y by itself, so I'm going to divide by 27, divide by 27, divide by 27. All right, these numbers are getting a little bit crazy here, but that's okay. I'm going to do a little bit of simplification up here, and that I know that 27 is 9 times 3. So those 9s will cancel, which is going to leave me with a 1/3 x minus, and then here I know that 36 is 9 times 4, 27 is 9 times 3, which means they will simplify to 4 over 3 equals y. So even though the y is on this right-hand side, it's still mx plus b on the left-hand side. And if you really don't love that, you can always rewrite it. But here's the point. The number in front of my x tells me what my slope is. So my slope here is a positive 1/3. So then I have to look at those slopes and I have to compare them. They are not the same, so I know it's not parallel. Are they negative reciprocals of each other? Well, I do have one positive and one negative, so that's a good start. And then here's the thing. If I flip the 1/3 over, I do get a 3 over 1. These are negative reciprocals of each other, and that means they are perpendicular. And that's what you're looking for. If the slopes are the same, they're parallel. If you can flip them and change the sign and get the other one, then they're negative reciprocals, and that tells you they're perpendicular. If neither of those things worked, then you would have a neither situation happening. All right, oops, sorry. I'm trying to get all the way to the top here for number 30. Number 30 says find the equation of a line giving the slope and the specific point. So they give you a point, they give you slope, so you are going to start with point-slope form. Point-slope form is another form of equation that we need to have memorized or you need to write down on your cheat sheet, and that it's y minus y1 equals m times x minus x1. This is just our starting point because it says find the equation of a line. If it asks you for the equation of a line, you will always, always, always give them something that looks like y equals mx plus b. And you are not done with your problem until you get to the mx plus b stage. So even once I plug in the numbers here, I won't be done until I get y equals mx plus b. So this works for what we're given because we're given slope and we're given just a random point. This random point is our x1, y1, like this. So when I go to fill in my equation, the y and the x without the subscripts, without those little ones, will stay my variables. But everything else gets replaced. So I have y minus my y1. Well, my y1 in this case is a negative 2. So I'd have y minus a negative 2. But minus minus becomes a positive. My slope is 3/4 times x minus my x1, which is a positive 2. Now, I'm not done because I'm going to have to get this y by itself. And in order to do that, I actually have to get rid of this set of parentheses first. So I need to distribute that 3/4 inside. So I have 3/4 times x, which is 3/4. And then I'm actually going to be taking 3/4 times the -2. So I'm going to go over to the side and I'm going to actually do that. I'm going to take 3/4 times a -2, but I'm going to stick that over 1 because that's how we would do it. We would stick our whole number over 1. And then again, I'm going to choose to simplify before I multiply. What I mean by that is I know I have a 2 up here, and I know I have a 4 down here. So this is like saying I have a -1 times 2, and down here it's like I have 2 times 2. Well, I have a 2 on top and a 2 on bottom. Those are going to cancel. That leaves me with a -1 times 3 on top, which is a -3, and down on bottom I have 2 times 1, which is 2. So that's going to leave me with a -3 over 2. Don't be scared to go to the side and do side work if you need to on these problems. Y is still not by itself. I have a +2, so I need to subtract, 6, what am I doing? Subtract 2 to move it over. And again, I'm going to have to go to the side to do some side work because I have 3/4 x, but then I have a -3/2 minus 2. So I'm going to come over here and I'll do -3/2 minus 2, but again, I'm going to stick that as over 1. But in order to do subtraction, we have to have a common denominator. So I have a denominator of 2 and a denominator of 1. So my common denominator would be the 2. It's going to be whatever's over here. So I'm going to multiply the -2 over 1 by 2 over 2, because if I multiply the bottom by 2 in order to get the 1 to turn into 2, I have to multiply the top by 2. The way I've always described this is that it's like you have a slice of pizza, but you've got to split it up so that you can give each of your kids a piece of that pizza. Like, I have this big of a slice, but I got to cut it in 2 to share it with both of my kids. And so that's all I'm doing. The amount of pizza I have doesn't change, it's just that I made it into smaller slices. So I have a -3 over 2, and then here I will have a -4 over 2. Now they have like denominators, so I can do that subtraction. -3/2 minus 4/2 will give me a -7/2, and this is the equation of a line through the point 2, -2 with the slope of 3/4. So over here in my box, I would write, and it says write the equation, and I'm not going to actually write it in the box just because of space, but I would write y equals 3/4 x minus 7/2. And they were even nice enough. It says type your answer in slope-intercept form. That's the y equals mx plus b. They kind of spoon-fed you on that one. Remember, always read the stuff in the parentheses so you know what you're actually supposed to be giving them and you don't miss out on those points. All right, let's do another one. It says write the equation of a line with the given properties in slope-intercept form, aka we need it to look like y equals mx plus b when we are done. But here's the thing. We're writing the equation of a line that runs through the points -3, 1 and -1, 3. We're not given any slope, but we are given 2 points, and if we are given 2 points, by golly, we can find slope. Because again, slope is y2 minus y1 over x2 minus x1. And if you want to memorize it, write it down every time you use it, and you will memorize it faster. I am going to label them x1, y1 based on the order that they're on my paper. That means the first point will be x1, y1, second point will be x2, y2, and again, if you do it the other way, you will still get the same slope. y2, as I have it labeled, will be 3 minus my y1. Oh, but my y1 is the -1, guys. So a negative becomes a positive. x2 is a -1 minus my x1, again, negative becomes a positive, like this. So I have 3 plus 1 is 4, -1 plus 3 is 2, so I find that the slope is a positive 2. So I'm going to make a note here. Slope is 2. Now that's great. But now I have 2 points and I have slope. I do not have y equals mx plus b, but that's okay. Literally just did this whole big problem where we had slope and a point. Well, now we have slope and 2 points. So we're going to do the same thing that we did on the last problem, and that we're going to use our point slope form, the y minus y1 equals m times x minus x1. We found our m, and you can use either one of the points, guys, either one of the points. I will tell you though, I'm going to use the first point simply because it's already labeled x1, y1, and this equation has x1, y1. That's why I'm going to use it. If you want, you use the second point, and you're going to see we get the same thing as long as you do your math right. So y minus my y1, well, my y1 is a negative 1, so minus minus becomes a positive, equals m, which we just said is 2, times x minus my x1, but my x1 is a negative 3, so minus minus again becomes a positive 3. Don't know about you, but this one's actually a lot easier than the last one because there's no fractions, guys. We have y plus 1 equals, we distribute the 2 to the x, giving me 2x, distribute the 2 to the 3, giving you a plus 6. To get y by itself, you minus 1, and you get y equals 2x plus 5. We love that. I can actually write that one in my box, where y equals 2x plus 5. And again, it says simplify your answer, or type your answer in slope-intercept form. They're telling you exactly the format that they want you to use. So make sure you use it. All right, number 32, determine the solution to the systems of equations graphically. If the system is dependent or inconsistent, so state it. All right, so what do we got to do? Well, we got to write both of our equations in y equals mx plus b format, and then we will graph both of them. That's what we have to do. So I'm going to do the first one in blue. If you're colorblind, I'm sorry. If you go along with me, you'll be able to keep up because I'm going to do each of these separately. I'm going to do y equals mx plus b. I'm going to make my notes, and then I'm going to go graph it, and then I'm going to do the second one. So my top equation is 3x minus 4y equals 0. I got to get y by itself, so I'm going to subtract the 3x over. So I have a negative 4y equals a negative 3x. Divide by negative 4, divide by negative 4. And I get y equals negative divided by negative is a positive. So we'll have 3/4 x, and that's all I have. So this is very similar to a problem we had earlier in that there's no plus or minus out here. Remember I told you, you could put plus 0 if that makes you feel more comfortable. So that way you note that your slope is 3/4 and your y-intercept then will be 0, 0. Slope is positive vertically because it's positive 3, so that means up, and it's positive horizontally, which means to the right. So I'm going to go ahead and go to my graph. And I'm going to drop the 0, 0. And then I go up 3, 1, 2, 3, and to the right 4 before I drop my second point. And then I'm going to connect them. And again, in Pearson, it would automatically connect for you. Ta-da! All right, so there's the top line. Now we'll look at the bottom line, which I'm doing in red. But again, if you're colorblind, hopefully you can keep up with me because now I'm working on that bottom line. We have x plus 5y equals 0, and I'm going to do the exact same thing I did on the last one. I got to get this in y equals mx plus b format. So I subtract my x over, and I have 5y equals a negative x. Divide by 5, divide by 5, and I get y equals, remember, even though we don't write it, if there's a negative in front of our x, it's like we have a negative 1. So it would be a negative 1/5 x. And there's no plus or minus again, so you can do the plus 0. I apologize that it's running into my work from an earlier problem. But this tells me my slope is a negative 1/5 and that my y-intercept is 0, 0. The negative on top is my vertical change. That means I'm going to go down 1. The number on bottom is my horizontal change. It's still positive, so I shoot to the right 5. So notice though that my y-intercept was the same. I'm starting at 0, 0, but I'm going to go down 1 to the right 5 to plot my next point. And then I connect my 2 points, and then we're going to have to think about what this tells us about our system. Because we've graphed it, and then it says, what is the solution to the systems of equations? Do we either have to type in ordered pair, or we say it's dependent, or we say it's inconsistent? Well, do our lines cross? Yes. If they cross, then you're going to be typing in ordered pair. And here's the deal, guys. They will always cross at a nice intersection. You're never going to be guessing if it's like 2.5 or 2 1/3. It's going to cross at a nice intersection. And in this case, we actually already knew where it was going to cross, because when we wrote them in y equals mx plus b format, we had the same y-intercept, which means they crossed at the exact same spot. So my ordered pair of where they cross is going to be 0, 0, just like that. Now, if it's a dependent system, you actually only graph one line. They will lay right on top of each other. The dependent system is where you have the exact same equation twice. You might not know that once they have it written up here, but once you write it in y equals mx plus b format, they will have the exact same slope and the exact same y-intercept. If you have an inconsistent system, that's where when you graph them, they're a set of parallel lines, so they never ever cross. So they don't have a crossing point. They don't have a solution. All right, let's slide on down. Sorry about my arm. Slide on down. Determine the solution to the system of equations by substitution. And they give you the system, and they were even so nice that they gave it to you where one of your variables was already completely by itself. And we love that when we were told to use substitution, because it's telling me that x is y minus 3, and if that's what x is, I just plug that into the second equation in place of my x. So I'm going to come down here to do some of this work because I just don't have a lot of space on this page. But it says 3x minus 5y equals a negative 21. But instead of writing x, I get to write the y minus 3 because that's what x equals. Then minus 5y equals a negative 21. Now I have one equation with one variable. I can solve that. In order to get rid of the parentheses, I have to distribute the 3. So 3 times y is 3y. 3 times a negative 3 is a negative 9, and then I write the rest of the equation as it is. And then I look at it and I say, okay, well, I have 3y minus 5y. Those are like terms, so I can combine those. 3y minus 5y would give me a negative 2y minus 9 equals a negative 21. To get y by itself, I have to add the 9, so negative 2y equals negative 21 plus 9 will give me what? A negative 12. Divide by negative 2, divide by negative 2. Y equals negative 12 divided by negative 2, positive 6. So the y component for my solution is going to be 6. And here's the deal. If I know what my y is, I can plug that back in because x is y minus 3. X equals y minus 3. But we just found out that y is 6, so that's 6 minus 3, so x is 3. So remember, an ordered pair, which is what I have to type in, has the x component first and the y component second, and I have to have parentheses, so 3 comma 6. So we found the y component first, but we still are going to list it second because in ordered pair it goes x and then y. So be careful with that as you work through these problems. Oh, look at that, same thing, doing the exact same problem. I mean, different numbers, but the exact same thing. It says we're going to solve the system, but actually, look at this. They're telling us to use the addition method. Now, how does Pearson know if you're choosing to use the addition method versus the substitution method or vice versa? Guys, they don't. They really don't. You could have done the addition method on the last problem, or you could choose to use the substitution method on this problem. However, if they ask you to use the addition method, odds are that's the easiest method. So I'm going to use the addition method. And so it's already set up nice and neat for me in that my x's are lined up, my y's are lined up, and my numbers are lined up. But if I were to add them right now, like my x's wouldn't go away and my y's wouldn't go away, so it's not ready. I'm going to have to multiply one or both of my equations by a constant so that one of my variables will cancel. And honestly, I'm going to look, and I'd rather play with the smaller numbers, so I'm going to try and get rid of my y's. Because I have a 2y, a positive 2y on top, and I have a negative 8y on bottom. They're even opposite signs, which we love. So the question is, can I turn a 2 into an 8 with multiplication? And the answer is yeah, I can. How? Well, 2 times 4 would give me a positive 8, and then these would cancel. So I need to multiply this whole top equation by 4. If I do that, my y's will cancel, everything will be wonderful. So I'm going to end up rewriting that second equation again, just so that you can, because I'm going to have to do it over here. But 9 times 4 is 36x, plus 2 times y, or 2y times 4 is 8y, equals a negative 8 times 4 will give me a negative 32. Bottom equation staying exactly the same, so I'm just rewriting it so that it is underneath. And then I'm ready to do my big vertical addition. But look what happens. I have a 36x minus 36x, those cancel. I have an 8y minus 8y, those cancel, which means I have nothing on that left-hand side anymore. And I have a negative 32 plus 33 equals 1. Does 0 equal 1? No. And so since I got a false statement, that means there is no solution. If I had gotten 0 equals 0, then there would have been infinitely many solutions. Or if only one of my variables would have disappeared, then I could have solved it the rest of the way to figure out the ordered pair. But in this case, we have found that there is no solution, which means this is an inconsistent system. All right, we've got our mixture problem. And I will use a table for our mixture problem. This is a birdseed problem straight out of 3.4. But, I mean, I know it says straight out of 3.4, and yes, it says it's out of 9.5, because remember, a lot of the problems from 9.5 are exactly the same as the ones from 3.4. In 3.4, we used a table. In 9.5, we used a systems of equations. And I'm actually going to do a little bit of both. I'm still going to use the table to organize my information, but I am going to use systems of equations in order to actually solve this problem, because I like the table to keep everything organized, because there's a lot of information in here. It says birdseed costs 57 cents a pound and sunflower seed costs 87 cents a pound. Angela's pet store wishes to make a 30-pound mixture of birdseed and sunflower seeds that sells for 81 cents per pound. So how many pounds of each type of seed should she use? So much information, which is why I like the table. So I know I have birdseed. I know I have sunflower seed. And I know I'm going to have the mixture. These are my 3 types of products, I guess you could look at them. And then next I'm going to talk about the number of pounds. I'm going to talk about their cost. And then I end up with the amount at the end. And I'm going to fill in everything I can from what they give me in the problem. I know the cost of the birdseed is 57 cents a pound. I know the cost of the sunflower seed is 87 cents a pound, and I know that they want to sell the mixture for 81 cents a pound. The only other number I am given is that they want to make a 30-pound mixture. So that's the number of pounds down here. That is all the information I am given, and I have to fill in the rest. So we have systems of linear equations now, so I am very okay with putting, I'm going to have X amount of birdseed, I'm going to have Y amount of sunflower seed. And then if you remember, the way that we get our amounts column is we multiply across our rows. If we multiply across our rows, we get 0.57X, 0.87Y, 0.81 times 30. You could actually do that calculation here if you wanted to. I usually wait to do it later. But now our table is completely filled out. So how does that help us? Well, this column gives us an equation of X plus Y equals 30. The number of pounds of birdseed plus the number of pounds of sunflower seeds has to add up to 30 pounds of the mixture. And this gives us our other equation. We have 0.57X plus 0.87Y equals 0.81 times 30. I have 2 equations, 2 unknowns. I can solve this using either the addition method or the substitution method, But for similar reasons, I'm going to choose to use the substitution method because I can get one of these variables by itself pretty easily. So I'm going to choose to get x by itself. How do I do that? By subtracting the y over, so that I have x equals 30 minus y. And if x is 30 minus y, I can substitute that in for my x in my other equation and solve. So I have 0.57 times x. Well, x is 30 minus y plus 0.87y. And then I'm going to go ahead and do the 0.81 times 30. And that'll give me a 24.3. Over here, I can't do anything inside of my parentheses, so I'm going to take 0.57 times 30. That'll give me a 17.1, and I take 0.57 times the negative y, so it's 0.57y plus 0.87y equals 24.3. I do have some like terms, and then I have negative 0.57y plus 0.87y, so I have 17.1 plus 0.30y equals 24.3. I'm going to need to get y by itself. So what I'm going to do is I'm going to subtract the 17.1 over. So I have 0.30y equals 24.3 minus 17.1 will produce a 7.2. Then to get y 100% alone, oh, I'm so sorry. So sorry, I wasn't moving it up. To get y 100% alone, I would divide by the 0.30 on both sides. Divide by 0.30. And I find that y is 24. And again, I love my table. I love my table so much because at this point I'm like, I have no idea what y was. I really don't. But my table tells me y is the number of pounds of sunflower seed. That'll be 24. And here's the deal, if I know how many pounds of sunflower seed I have, I can substitute that in and figure out how many pounds of bird seed I need. Because bird seed is x equals 30 minus y. We just said that y was 24. 30 minus 24 is 6. So it means we need 6 pounds of bird seed, 24 pounds of sunflower seed to make this mixture the way that they want to have it. And again, look at the answers I got, guys. Oh, bird seed is going to be 6 and 24. I got nice numbers. You shouldn't be getting decimals on this. You're going to get nice numbers. So be aware of that, okay? All right, we're actually nearing the end. Number 36. Solve the inequality and graph the solution on the number line. So remember, when we solve inequalities, we do them the exact same way we do equations, but if we have to multiply or divide by a negative number across our sign, then we flip our sign. That's the difference. But the way that we really work these is exactly the way we'd work it as an equation. The negative 3x minus 17 is less than 7. If this was an equation, I'm concentrating on getting x by itself, so I'd have to add the 17, add the 17. I get a negative 3x is less than 7 plus 17. That's 24. To get x 100% alone, I'd have to divide by negative 3, divide by negative 3, and then my alarm bells are going off because I divided across my inequality by a negative, which means I'm going to have to flip my sign. Instead of x is less than, I'm now going to have x is greater than. I have a positive 24 divided by a negative 3, which will give me a negative 8. I had to flip it because I multiplied or divided by a negative number. I actually found an inequality, so it says type an inequality, simplify your answer. So I would be x is greater than negative 8. Then I come down, I have to pick my graph. Well, all of these have a negative 8 listed except for E and F, so immediately I know it's not E, it's not F. I don't have to worry about those. If you have a filled in dot, like you do on A and D, that would be if it was greater than or equal to or less than or equal to, so I know it's not these, so it's either B or C. which way is graphed in or shaded in so that x is greater than the -8? It's going to be C. All right, flip that over. We're going to do another one. But we don't have to do the graph on this one. It just says solve the inequality and give the solution in interval notation. So we do have to remember interval notation. This is a compound inequality. So I'm going to put the paper up here so I can have a little bit more room to do it. I have 16 is less than or equal to 6 minus 5g, which is less than 20. So really what we can do is you have two options. You can split it into two separate inequalities, or you can keep it as a three-sided inequality. Personally, I really like to keep it as a three-sided inequality. So what that means is I'm looking here at the middle, and I want to get g by itself. And if I was trying to get g by itself, and this was all we had, what would I do? Well, I would subtract the 6 over. Here's the deal. If I was looking at this inequality and I was trying to get g by itself, the first thing I would do is I'd subtract the 6. So I'm going to do that on all three sides. Subtract the 6, subtract the 6, subtract the 6. 16 minus 6 is 10, less than or equal to -5g, is less than 20 minus 6, which is 14. To get g by itself, I would need to divide by a -5. But if I do it to the middle, I gotta do it to all three sides, and then my alarm bells are going off again. Why? Because I divided by negative. So all of these are gonna flip. 10 divided by a -5 will give me a -2. And then instead of less than or equal to, it's now greater than or equal to. The -5's cancel there, leaving me with a g, which is strictly greater than. And then 14 and 5 have nothing in common, so it's just -14/5. Now, the number one mistake students do is they will look at this and say, okay, when I have to go write my interval notation, I put my lower limit on the left and my upper limit on the right. And so they would put -2 as their lower limit and -14/5 is the upper limit, and they would go from there. But that's not what this says, guys. It says -2 is greater than or equal to g, which is greater than -14/5. That means this is actually the smallest value. This is our lower limit. What I recommend doing is, since all of this is backwards from the way we usually like it, I'd write it the other way. We have -14/5. Like, I'm writing it like I'm reading it from right to left. -14/5 is less than g, which is less than or equal to -2. Why do I do that? Because now it reads in the right way that we want it to, where the lower limit's on the left and the upper limit is on the right. Because now it says -14/5 is less than g, which is less than or equal to -2. And when I put that then on my interval notation, that means I'm going to have the -14/5 on the left and the -2 on the right. Since g is strictly greater than this -14/5, I use a parenthesis. And since g can be equal to, I'm going to use a bracket. Do you have to write it in this order? No, but you have to recognize what it says here, and that it says -2 is bigger than these two other things, which means -2 is your upper limit. It's your larger number. So it has to go on the right, because if you put your lower limit on the right and your upper limit on the left, you're wrong. Lower limit always goes on the right. So again, I'm not going to write that inside of my box. I'm going to write it to the right of my box simply because I want to have space to write it. Oh, so sorry. There you go. So be really careful about that. That flipping action means that the order changed, and we really have to pay attention to that when it comes to how we write our interval notation. All right, graph the inequality. So when we graph inequalities, we do the same thing like it was an equation, except that we're going to use a dashed line if it's strictly greater than or less than, and we're going to shade a region of our graph. So the first thing you want to do is you want to write it in y equals mx plus b format. And yes, it won't say equals. You'll have an inequality symbol instead, but you still want to write it in that format. So I have 2x plus 4y is greater than 8. I want to get y by itself, so I start by subtracting the 2x. To both sides. So I get 4y is greater than -2x plus 8. And again, I wrote my x term first because I want it to look like mx plus b. Divide by a positive 4, divide by a positive 4, divide by a positive 4. So I get y is greater than negative 2 over 4 simplifies to a negative 1 over 2x. 8 divided by 4 gives me a positive 2. This is the inequality written in y equals mx plus b format. That's what I want to work with. Because from here, I know that my slope is a negative 1/2. I know that my y-intercept is 0, 2. And furthermore, I'm going to look and say, okay, y is strictly greater than. So I'm going to use a dashed line. And this information right here, which I'll highlight or circle in a different color, is what I need to graph with. Because I'm going to go to my graph and put my y-intercept, which is 0, 2, right there. And then I use my slope, which is a negative 1/2. The negative 1 on top tells me vertical movement is going down. The 2 on bottom is positive, so it tells me I'm moving horizontally to the right 2 units. So from 0, 2, I move down 1 to the right 2, and I drop my second point. When I connect them, I'm going to make sure and use a dashed line. Dash, 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 dash. And now I'm almost done, but I have to figure out whether I'm going to shade this region down here or this region up here. And I told you there's a little trick, or the safest thing to do is to always just put in an ordered pair and test it and see if you're right or wrong. And I've told you that in general, if 0, 0 doesn't live on your line, I use 0, 0 as my test point. So I'm going to tell you the trick, but then I'm also going to test 0, 0, so that way you see it both ways. The trick is when I write it in y equals mx plus b format, notice it says y has to be greater than all the rest of this. So if I look at this line, that's all the rest of this, my y needs to be greater than that line. So look at my y values on either side of my line, down here and up here. Which y values are greater? Is it the negative numbers down here or the positive numbers up here? Well, it's the positive numbers, right? So my trick would say I am going to end up shading on this upper or right-hand side of the line. That's where I'm going to shade. But I'm going to do a test point just to make sure, and I'm going to plug it into the original problem. So I'm going to test the point 0, 0 because it doesn't live on my line, and algebraically it's the easiest one. And I'm going to plug it into the original. So it'd be 2 times 0 plus 4 times 0 is greater than 8. Well, 2 times 0 is 0, 4 times 0 is 0, so that means I have 0 is greater than 8. Is that true? No, 0 is not greater than 8. 0 is less than 8, which means I would not shade the side that has 0, 0. I would shade the other side. So I like my trick because it helps me to know which side I should be shading. But if you want to pick a test point to guarantee that, then do that, because that is the safest way to do it. All right, graph the following inequality. Look at that, we have y is less than 8. Look at that, it's just like the problem we had earlier, in that we have y equal a number. That means it's a horizontal line at that number. So up here at 8, but I'm going to use a dashed line. And the question is, am I going to shade above that dashed line or below it? It says y is less than 8. So where are my y's less than 8? Are the y numbers down here less than 8, or are the y numbers up here less than 8? Well, the y numbers down here are less than 8. So I would shade the region below the line. On to our last and final problem. Determine the solution to the system of inequalities, and I'm going to have to do it bit by bit. First thing I'm going to do is I'm going to look at this top equation. It is not written in y equals mx plus b format, so that is my first thing. 2x minus y is less than 2. Got to get y by itself. There's different ways you could approach this. You could move the x over, or you could just move the y over. I'm going to try and stay consistent in that I usually leave my y on the left-hand side. So I'm going to choose to move my x's over. So I have a negative y is less than a negative 2x plus 2. To get y by itself, I'd have to divide by negative 1, divide by negative 1, divide by negative 1, and alarms are going off because I divided by a negative. So it'll give me y, and instead of being less than, it's now greater than. Negative 2 divided by negative 1 is a positive 2x. Positive 2 divided by negative 1 is a negative 2. So there's the top equation written in the correct format. And I'm going to make my 3 notes. I'm going to note what my slope is. My slope is a positive 2, and since it's a whole number, I'm going to write it over 1. That way I can indicate the slope movement of going up 2 units and to the right 1 unit. I'm going to note my y-intercept, which is 0, negative 2, and I'm going to note that since my y is strictly greater than, I will be using a dashed line. These are the 3 pieces of information I want to know about each of my inequalities for when I go graph them. And so I'm going to go ahead and go over here and I'm going to graph it. I have 0, negative 2, so that's down here. I'm going to go up 2 units to the right 1 unit to plot my second point, and I'm going to be careful and I'm going to use a dashed line. And then before I move on to my next inequality, I'm going to use my little trick to make my little arrows. Because my inequality says y has to be greater than this line. So looking just at this line, are my y's greater down here or are my y's greater up here? Well, they're greater up here, right? So I'm going to do my arrows to where they're pointing upwards or to the left towards the greater y values. Okay? And then I'm going to go look at my second inequality. And luckily for us, this one's written in the format we like. It's already there. It says y is greater than or equal to negative x plus 3. So the slope, notice there's a negative in there, is a negative 1 over 1. Again, I made my whole number into a fraction so I could note the vertical movement is down 1, the horizontal movement to the right 1. My y-intercept will be 0, 3. And since I have a solid line in my inequality, so it's greater than or equal to, I'll be graphing with a solid line. This is the information I need to go put on my graph. So 0, 3, I come up here to 3, drop it. I go down 1, right 1, drop it. And then when I connect them, I'm going to connect them using a solid line. Okay? And then on top of this, I'm going to think. My inequality said y had to be greater than this solid line. So thinking only of my solid line, are my y's greater above it or below it? Well, they're greater above it. 4 and 5 are bigger than 2 and 1. So that means that I would need to shade above my solid line. So then the question becomes, what is the region where both the blue and the green arrows point to? Up here. This region is the only region where both the blue and the green arrows point to it. So I want to pick my test point from up there. And guys, I usually pick my test point as like an intercept because it makes one of my values 0. So I'm going to pick the test point right here. I'm going to test 0, 4. It is a point that doesn't live on either of my lines, and it lives in the region where I think I'm going to shade. So I'm going to test the point 0, 4, and I'm going to test them in the original formulas, the original inequalities up here, not the ones I messed with, in the originals. So for that top one, I would have 2 times my x value, which is 0, minus my y value, which is 4, is less than 2. 0 times 2 is 0, so I have negative 4 is less than 2. Well, that's true. Negative 4 is less than 2. All right, so it worked in the top one. That's good. We got to make sure it works in the bottom one. If it works in the bottom one, we're good to go. So our bottom one says our y value, which is 4, has to be greater than or equal to negative x value plus 3. Yes, I know writing negative 0 is weird, but I just wanted you to see where I'm getting my numbers. So it says 4 is greater than or equal to 3. 4 is greater than 3. Hey, it worked. So instead of testing random values, I knew to test a point from up here. I got a true statement, so I know to shade this region. You will only ever shade one region, and only one region, regardless of how many different regions you have. So once you find a true statement, you're done and you're good to go. And that's the way you can kind of shorten up these problems a little bit.